Hello. Thank you so much for joining us today for our very first session of the Parks College weekly webinar series. My name is Amy Price, and I'm the outreach coordinator here at Parks College. I'm joined today virtually by Dr. Swartout, who will be showing us around the Space Systems Research Lab. We're so excited to have you joining us today from wherever you are. Thanks for taking the time to virtually visit us and learn more about the engineering programs at St. Louis University. In total, Parks College has programs available in aerospace, biomedical, civil, computer, electrical, and mechanical engineering, as well as flight science and aviation management and engineering physics. We hope you'll see or hear something today that piques your interest. Before we start, I wanted to give you an idea of how the webinar will flow. I will soon introduce Dr. Swartout, who will be showing you around the Space Systems Research Lab and sharing information about our engineering programs. He will then introduce Parks students Celia and Connor, who will share their experience of being engineering students with you. Finally, we will conclude with time for questions and answers. Please submit any questions you may have throughout the presentation to the Q&A feature at the bottom of your screen if using Zoom, or in the comment section if on Facebook Live. And we'll do our best to answer as many questions as possible at the end of the presentations. Throughout this webinar, you don't need to worry about turning off your microphone or your camera. You can hear and see our presenters throughout the webinar, but we cannot see or hear you. Finally, if you have any technical difficulties during the webinar, please email parksevents@slu.edu, and we'll do our best to address issues that arise. This session will be recorded and posted to our YouTube page by early next week, and you'll receive an email with that link when it becomes available. And now, with our housekeeping out of the way, I am happy to introduce Dr. Mike Swartout and the Space Systems Research Lab. Dr. Swartout, I will turn it over to you now.
All right, thank you, Amy. Good morning or afternoon, depending on where you are. As Amy said, I'm Dr. Swartout. I am a professor in the aerospace and mechanical engineering programs, and I sponsor the Space Systems Research Lab. So I'm glad that everyone is here. Thanks for joining us. I don't want to spend as much time talking as I usually like to talk, so I will try to be focused and give time for the students and also for the questions. So at the risk of under talking about what we're doing, so Space Systems Research Lab is we're building spacecraft. I think that one of the best educations that I can give an undergraduate student is the opportunity to be engaged in hardware that ends up going into space. So this is a largely student-run program, and we have the luxury of two of our current and former program managers. So the students who were running the program are going to be with us. So when I say we're building satellites, these are small satellites, but still very effective satellites. So the scale I'm talking about is this big. This is an engineering prototype. It doesn't have solar panels because solar panels are really expensive for space-ready, for space-qualified solar panels. So we only buy those for the things that are going to go into orbit. But this is the scale of the spacecraft we're talking about. You can see it's a metal frame. It has electronics on the inside. And so one of the important things that I always like to sell with this is that we have a lot of need for students interested in electronics and programming. Even if you're a mechanical engineer or an aerospace engineer, you will end up learning a lot about electronics and programming. As you saw, that's a large element of what goes into a spacecraft. So again, this is students come in. This is for all of our majors. As I said, they're coming in from a wide range of backgrounds. Some have worked robotics camps and clubs as a high school student. Some have had no experience whatsoever. And so our interest and intent is to bring in new students, give them the tools they need. They learn things in class. A lot of this is out of class. We have summer activities, and they go ahead and build. While I'm talking, let me pull up some pictures of the kinds of things that I'm talking about. And, oh good, it actually saved the things that we had before. So apologize for a second while I push some buttons here. So what you're looking at there, this is the spacecraft that we launched just earlier this year called Argus 2. There's actually two spacecraft in there. The second one in there called HARP actually won the mission of the year. So we were adjacent to greatness, you can think of. But this is one of our alumni, Connor Highlander. He is now working for Northrop Grumman, and he is down in Texas, as you can see by the flag behind you or behind him, That is putting it into the ejector tube. That tube was carried up on a rocket to the International Space Station. It was bundled with a number of other tubes, and then it was put on orbit. And again, it was sent into orbit this last February. All right, this is actually the first Argus. This was Argus 1. Those are two of our alumna. Kate is, actually, she used to be working for a rocket company, but she's back at grad school. And Mary on the right is working for Northrop as well. So they're doing the final integration and our traditional bunny ears photo with Argus 1 that was delivered several years ago for launch. This is just what it looks like in our lab space since we don't have the students in here. So wearing personal protective equipment, masks, et cetera, I guess is fairly normal for us, although usually it's for the protection of the spacecraft, not for us. But these are all, at the time, undergraduate students who were working on, actually that's them assembling the Argus spacecraft. On the left is Nate. Nate is now an engineer at the Jet Propulsion Laboratory. On the right is Janana. She is also working for Northrop Grumman. You'll hear that a lot. We're getting a lot of students hired by them these years. And we send a lot of students to Boeing, of course, as well, since they're local. So that's just to give you a picture of what's going on. And speaking of pictures, this was taken about 20 minutes ago. We have two labs in terms of lab spaces. This is the primary design lab, which is down the hall. And so rather than have you watch me run up and down the hallway, I just decided to take a picture of that. So that is the first of our lab spaces. And honestly, I thought about cleaning, but then I realized that I would be misleading you. This is what an active lab looks like in terms of students working in it, working on various electronics, doing analysis, doing design work. When we can have group meetings, large group meetings, we would have them in this room as well. So assuming I can operate things, oh good, correctly. Now what I want to do is take you on a quick tour of this room. So apologize if I make it busy here. I'm going to flip my camera around, assuming that it will let me. Excellent. Okay. So again, speaking of clutter, this is our mission operations room. So I'm sitting at the mission operations station, which is currently inactive because we don't at the moment have an active spacecraft. So that would be sitting there. Over here is the display area, but I want to show you the more interesting things because right now we are in the midst of designing and building a set of small spacecraft. The mission's called Dory. It will have at least 2 spacecraft. Shameless plug, come to Parks, work with us. Our intent is to launch 5 of these in the next 5 years. So if you want to get your fingerprints on something that's going to go into space, please come join us. This is one of our test rooms. What I'm pointing at is a vacuum chamber that we use for doing detailed environmental testing. One of the things that we need to pay attention to is since we're taking a lot of parts that were not designed for space and using them in space flight, we want to do some extra rigorous environmental testing. So we have a vacuum chamber rigged up. Those items would go in here. This gigantic lid can be placed on there. And so that seals up, it pumps it down, and we can observe its behavior in a vacuum. That often changes the thermal behavior. Sometimes there are particulates that will evaporate out. And so we want to do the test and make sure that everything's going to be safe and good to fly. This actually was a project. He was a graduate student, but I had a graduate student do this as part of his master's work. He built this, set it up, and got it all up and running. All right, trying to walk in a way that's not going to make you dizzy. Just next door, conveniently, is our clean room. This is where the magic happens. This is where the spacecraft are assembled. So the pictures you were seeing before, we were in a slightly different location, but it's the same equipment, the same setup. So some of the hardware that we're going to build for the Dory flight spacecraft has come in. You can see it sitting in those shelves down there. So the students are responsible for bringing in the hardware, for doing the assembly, doing the checkout. We're not going to go back behind there because I'm not going to spend the time to get gowned up. But so we have all the protective equipment here. We go in and do the work. That squishy noise you may be hearing is I'm standing on a sticky mat that is used to remove as much dust as possible and dirt off of my feet before I go into that room. So that's the work that's being done in there. Now we're going to flip back to look at me. Okay. That. All right, so now I will make you a little bit dizzy, but I walk back over here. We typically have a couple of dozen students working in the lab. As I said, they are ranging in experience ranging in age group. As I said, I teach in the aerospace program. And so there is the opportunity to concentrate in more space-related courses. I teach courses in spacecraft design, mission failure. That's related to my research work. But there are a lot of opportunities for students to get engaged if they're interested in space, which is, again, the focus for this one. But certainly in later webinars, Amy will host you through a lot of the other activities going on. So with that, again, making time for questions, I want to give a little bit of time over to Celia and Connor, who are going to introduce themselves and talk about their activities and experiences in the lab. So why don't, yeah, thanks, Celia. I will stop.
Great. So, hi, I'm Celia. I'm a current senior here at St. Louis University. And so a little bit how I came to SLU. During my college search, I wanted to find a college that was small enough that I could find or have the opportunity for those close one-on-one relationships with professors. I just didn't want to be one student out of 100 plus other aerospace engineers or other engineering majors. So I really had that great opportunity at SLU. I've been able to work with Dr. Swartout and other professors one-on-one. I'm not just a number, but SLU isn't too small that it feels like I'm at a tiny high school. I really enjoy the size. And so like Dr. Swartout said, I currently serve as program manager for the Dory mission. And so that's, like he mentioned, multiple satellites. So we're about halfway through the official design process, and we'll have several reviews this year. And it's a Air Force Research Lab sponsored program. And so we do reviews with them and we're very involved with them. So it's a very structured program and we're just moving through the design process. And so I've had a great time in Space Systems Research Lab. I was involved from day one, freshman year. I worked as just a member on one of the sub teams. And then I had the opportunity to become program manager at the very beginning of this program, the second semester of my sophomore year. And since then I've been serving as program manager. And Connor Morris, we worked on that project during my sophomore year together. So I'll let him introduce himself.
Hello, everyone. My name is Connor Morris. I was the former program manager for the Argus 2 mission. I guess you could say I'm a super senior at this point. I've been around for quite a few years. And back when I joined in 2015, when I was looking for colleges, in high school, I knew I wanted to do something in space. So I was specifically looking for universities that offered these types of research labs to join as an undergrad. A couple of the other public schools I looked at offered these laboratories to join as a graduate student, but I didn't want to wait that long. So SSRL was the reason I actually came to Parks to pursue my education. I can tell you it paid off quite a bit, and I learned many things over the years. So currently in SSRL, I'm kind of serving as a flight software lead, having done some flight software and other software development projects in industry for the past 2 years. And I'm applying that to Celia's Dory mission today.
Awesome. Thank you both. Oh, Connor, are you still there?
Oh, yeah, I should be.
Okay. I thought you cut out. I'm sorry. Well, thank you both for being here and sharing some of your experiences. For anyone viewing right now, feel free to submit any questions that you have to the Q&A feature in Zoom, or you can just go ahead and comment on the Facebook post if you have questions for Dr. Swartout or Celia or Connor. But to kick off kind of some questions, Dr. Swartout, or I guess Celia and Connor, what recommendations do you have for high school students who might be preparing for an engineering program in college, and what can they do now?
I'll start with that. First, just as an important note, especially if there's teachers or parents, Connor is a super senior, not because he's been struggling with the coursework, but because he spent a very long time in a NASA internship, which again, if we're plugging ourselves, that's one of the opportunities that happen with students. So it's not anything shady or questionable on Connor's part, but
I promise I haven't failed.
Right, exactly. As a high school student, the things are, I would say, two things for me, and I'll let the students who are much closer to this chime in on that. For me, the things are, get as much of the math, science, technical background as you can, because engineering is a very technical language, and just having experience seeing things several times will help those things make sense. And the other piece would be to seek out those opportunities to make something with your hands, whether it's a robotics club, if it's something that you can do in a class, if it's something that you're doing on your own. Getting over the fear of building something and it not working, and especially learning the perseverance to make things work when they don't work the first time, will be very valuable for you in not only my lab, but in any sort of engineering experience.
I would say something that high school seniors or juniors that could do to prepare for an engineering major is just read stuff that interests you. Get stuck in a Wikipedia like wormhole, go through different things, like stay active on the news. There's definitely a lot of different resources out there, like AIAA is the aerospace kind of professional association. I think you can subscribe for their emails, and they'll send you a little link every day in your email, just staying up to date on the industry, because then you'll have a great knowledge base about what's going on, and you'll be able to learn about cool technology. So if you're interested in rockets, find some outlets that tell you about rocket news. If it's spacecraft, just find what interests you and learn a lot about it, because there's a lot of stuff about the news, and it's a really crazy time right now. So I think staying up to date with the industry would be really good.
And to add on to that, I'm actually adding a website in the chat that I like to go to. It's called Spacetubecom. You can see articles from the defense, the commercial, and the civil sector, which I think is kind of nice to see, a 30,000-foot overview of things that are happening in space today. But in terms of kind of like hard skills to maybe prepare you for your engineering courses and maybe even professional lives after school, I think it's definitely doable for high schoolers to start picking up programming. So I would highly recommend that if you have the time now while we're all stuck at home, to maybe pick up either Python or C++ and get some concrete skills in object-oriented programming that, as an engineer, as our products and industry become more digital and software-based, you're definitely going to need that when you move on to a job later on, as I have found out.
Fantastic, thank you. We did have a question come in. How long is the typical aerospace program? 4 years or more?
It is, yeah, Connor notwithstanding, it's set up to be a 4-year program. And so if I can put on my SLU sales hat, actually all of our engineering programs are scoped to be doable in 4 years, and especially scoped so that you can get into the classes that you need in order to graduate in 4 years. And this isn't such great news for the 2 current students here, a little late for them, but we're in the middle of renovating the curriculum just as a normal part of updating it, and it will be even easier to finish in 4 years. And so that's a commitment that we make, that this is a 4-year program.
Excellent, thank you. So both Connor and Celia, you touched on when you got started at the Space Systems Research Lab, but can we talk a little bit more about that, how students get involved, how early they can get involved, and who do they need to talk to? Do they join a club? How does that work?
Yeah, so I'm actually working through the recruitment process right now as program manager. So typically in a normal year, they'll be on West Pine, which is the street or the sidewalk that goes all the way through campus. There'll be a club fair, and so that has all the clubs across the whole university. And then there's also a parks fair exclusively, which happens in McDonnell Douglas Hall, the engineering building. And so all the different clubs will sit out. I believe we're doing it on Zoom this year, so we'll have different breakout rooms that people can come in, and so you'll be able to talk to all the different clubs, including Space Lab. And then from that, we'll go into like introductory meetings. But as always, we have a website that you can check out. You can get our email from there and just drop us an email, and then we'll be able to get you connected with the right people, which would usually be me or another program manager. Or you can you can find Dr. Swart out, and he'll get you contacted. So yeah, we want people to join first day their freshman year, because that just gives us more time and gives each person more time to get a lot of knowledge and a lot of experience. So definitely recommend first day freshman year. You can try out different clubs. So there's also the Rocket Lab. Try out different clubs, find what works for you, but definitely get started early on.
Yes, definitely. Especially for our freshmen that come into SLU, they have ample opportunities to check out all of the student organizations, all the student activities. So that's wonderful. If you end up coming to SLU, you can check it out then. So thank you, Celia. Dr. Swartout, can you talk a little bit more about what students who have come through the research lab, other careers that they've gone to? You've mentioned Northrop Grumman. Are there any non-aerospace specific students that pursued, you know, a little out of the ordinary career, or took something from the space lab and
Yeah.
applied it in their careers?
Yeah, so if we're talking about students who've come through this lab, so I guess first, maybe to make sure I may be answering the question or I'm answering a different question here. We've had 5 alumni working for SpaceX, 3 of which one was engineering physics, 2 were electrical computer engineering. So in the sense of, if I going to work for NASA, or if I'm going to go work for a ambitious rocket company, aerospace engineering doesn't have to be the major. If you have different interests, if you have different skill sets, there's definitely a need for those things. I think I've probably said that enough. As far as students who've come through this lab and then gone in different directions, yeah, I mean, that happens a lot. So we've had students going in lots of different directions. I've had alumni who started out in engineering and then moved into education from their background in terms of the skill sets and their interests here. Certainly if it's outside of just space, again, a lot are going to go, we've had a lot of alumni working for Boeing on the aviation side of things. And I'm trying to think of other specifics. I will say that because of the nature of a space lab, we tend to attract the students who want to use this as a springboard to a space themed career. So that is most of where our students go, but it by no means dooms you to a life of working in space. If you change your mind, the skills will transfer.
Wonderful, thank you. Celia and Connor, tell us about the coolest thing that's happened in the Space Systems Research Lab that you've been involved with.
Ooh, that's difficult. So probably for me, I had, Connor was also here alongside. I had a pretty unique opportunity to begin basically day 1 with the Dory program. So I've seen the mission from basically, we just have the proposal that Dr. Swartout wrote, and we need to make the mission statement and the success criteria. And so really being able to begin with the program day 1 and seeing it now a year and a half later is pretty incredible to see how undergrad students can progress so much. And then along with that, I've had the opportunity to travel to a conference called SmallSat out in Utah. It was part of the program that we're going through with the Air Force Research Lab. So we actually were able to attend the conference, which is funded by the program that we're in, and then go and present. So I've had the opportunity along with Connor and a couple other students to present multiple times in front of industry professionals. And so that's been an amazing opportunity to not only get the public speaking skills, but also be able to convey an idea and our mission in a way that other people will understand it. Because at the end of the day, you can be great at math, you can be great at engineering, but unless you can convey your idea and your amazing technology to someone else, it's gonna be a difficult sell. And so at the end of the day, learning how to convey ideas to someone who's never seen your mission before is an incredible skill that I've been able to grow here.
And then for me, the coolest, I'll give you 2. The coolest thing that I did at Space Lab was my first semester freshman year doing integration on Copper 2, which was one of the missions that would be in a polar orbit around the Earth, and its mission was to view the auroras. But that was my first time as a kid from Nebraska who grew up in a farm town to actually touch spacecraft hardware. And that pretty much just sealed the deal. It's like, yep, this is what I want to do with my life. This will be my career forever. So that was very cool to have that opportunity as a freshman. But what I will say is the coolest overall experience, and maybe this is a little unique to my situation, but when Argus 2, which was our most recent mission, launched off the ISS in February, I was actually working at Johnson Space Center down in Houston, and I was actually sitting at a flight controller desk, doing something else, but I actually got to see on the live feed from the ISS, our little guy pop out of the deployer and see, oh, that's my spacecraft on a bigger spacecraft. So that was a very cool and unique experience.
That sounds fantastic. Dr. Sordout, do you have any really neat experiences that come to mind?
Yeah, I mean, I think they're usually related to seeing something deliver. Although I have to say that I love to live vicariously through our alumni. It's a long-term alumnus of Parks in the engineering program. But the mission manager in charge of entry, descent, and landing on the most recent NASA Mars rover is an alum of our program. And then hearing about getting to go to SpaceX and getting the secret behind the scenes tour because we have alumni working there. So for me, the most exciting part is seeing the little bit that we do here and how these students take that and run with it. And then they go out and do some really fantastic things. That really is the most exciting part for me.
Awesome, thank you. We had a question come in. A group of students would like to know what specific jobs are in the career field. So we've been talking about kind of at large, SpaceX, Northrop Grumman. What's the day-to-day job? What would that entail?
So
what possibilities?
Yeah, I guess I can answer two versions of the question to make sure I understand it. One is, in terms of what are they doing day to day? Actually, I would throw this at Connor because he did something day to day for many months.
All right, so yeah, pretty much in engineering and specifically, aerospace, mechanical, even electrical and computer. Working at NASA, I supported a variety of different divisions and groups, and pretty much if you're an engineer, you are trained in your schooling to be trainable and to learn new tasks and how to perform them effectively. So, I worked in operations for a little bit, which is essentially you kind of like drive the spacecraft. You have tools in front of you and you view the data and then command the spacecraft to do various things based off of that telemetry, what we call. You can also do hard analysis. So if you're going to be truly engineering something and designing a new product or a new vehicle, you'd be doing structures analysis, power budget analysis, kind of your hard mathematics analyses. And then if you're more of a sales engineer or a system engineer, you're kind of looking at the overarching product or vehicle and either serving that up to your external customers or serving that up to your internal stakeholders or people who care about your mission to say, yes, this is a good mission, we are ready to go, or yes, we are ready to sell this product at X price, and things like that. But even as an aerospace engineering major myself, I've actually developed more into the software development side of things as kind of a true flight software developer. So you can either be working on the hardware or the software, and you can be doing it at any of the vertical capacities on either end.
Connor, can I interrupt? When you said you're sending commands to the vehicle, what vehicle are you sending commands to?
In my time at NASA, it was all three. So I supported the International Space Station program, Artemis, which is the Orion capsule, and then also Boeing CST-100 Starliner. So in simulations and even in the operations room, you would practice sending commands, or you would send commands to the real thing after a big procedure list. But you would command the spacecraft to say, point your spacecraft more towards the sun as we're coming over the Earth, or open up your solar panels to this degree, those kind of things.
Yeah, just back to living vicariously, I'm just noticing that he's sending commands to these actual big spacecraft in orbit.
That's very, very cool. We are just about at time. If there are any final questions, please go ahead and submit those now. But a last question for Celia and Connor. What's your favorite part about being a Billiken at SLU?
So I really enjoy the close-knit atmosphere of SLU. I'd say it's across the whole campus, and I feel like it's especially strong within engineering. I really enjoy the kind of close relationships that come with a smaller campus and a smaller class size. So I believe our aerospace class and similar engineering classes are about 45 per major. And so that's a really good group. We usually move throughout the classes together throughout the day. And so that's really enjoyable because I know everyone in my class. And so I can make groups with other people to study with. And so really making those relationships and having those, that one-on-one close-knit atmosphere I really enjoy about SLU.
And I'll extend on that a little bit. So my class was the class of 2019, and everybody except for myself has obviously graduated and have real jobs now. But just for example, in terms of close-knit, I mean, we went through undergrad for 4 years together, and right now our Snapchat group is still exploding with, you know, whatever Snapchats people are sending. And, you know, given the coronavirus times, we all get on it in the evenings and, you know, play video games together and whatnot. And we even stay in contact with each other as well. Currently there are, you know, now I think 10 people at Northrop Grumman out in Virginia. And over the past year, they've managed to convert me to the dark side of the private sector. So they rope-a-dope me into a job out there. So, you know, these are relationships that you found not only in your college career, but that will last throughout the rest of your career and personal lives and beyond.
Love it. Thank you, all three of you, Dr. Swartout, Celia, Connor. Thank you for being here today, showing us the Space Systems Research Lab and sharing your perspectives. To each of our viewers, thank you for attending our first webinar series session today. We hope that you enjoyed the virtual visit to the Space Systems Research Lab. If you would like to learn more about this lab, as Celia mentioned, please visit SLUSpacelab.com, SLUSpacelab.com, for more information and some really neat photos of what they're doing day in and day out there. We do hope that you'll join us in this webinar space again next week to visit the Biomedical Engineering program. We'll be looking at surgical robots in the additive manufacturing lab. That will be Thursday, September 10th at 10 a.m. Again, thank you for joining us and have a great rest of your day. Bye-bye.